Hello. Um, let's explain this website. As you can see, here is talking about the triangle, this one on here, and he set some definitions. This is the opposite for this. Let me show you here. This is really important. Now, if I made the triangle like this, okay, all sine and cosine has to be defined for the angle. So this is the angle, okay. Now when I say sine this angle, okay, I mean according to this angle. So if you went here, this is the opposite, this is the hype, I do not know its name in English. This is the hype, and the other one is the adjacent, okay. So sine this angle, is this the opposite? So this line is the opposite of this angle. So you say opposite over hype, okay. Now if I took this angle, everything is gonna be changed. Let me change it. Let's say that this is the angle, so everything is gonna be changed. The opposite is going to be on the other place, so this is going to be the opposite. Let me change the color. So this is gonna be the opposite, because the opposite to the angle. This is gonna be the adjacent. So sine this is the adjacent, as you see here. The opposite, actually, I'm sorry, the opposite in here over hype. So it all depends on the location of the angle. Be careful about the location of the angle. This is the first thing. The second thing, gave you a description on here. Since the trigonometric ratio do not depend on the size of the triangle, you can always use the right angle triangle where the hypotenuse has the length 1. If you place such a triangle on a Cartesian system as the applet above, the vertex A, where is the vertex A? Okay, so this is the vertex A. Will lie on circle with radius 1. A circle having the radius 1 is called a unit circle. Now saying the value of sine and cosine are okay. I got it. He simply draw a circle, okay. What he wants to explain is the relationship between sine, cosine, tan, cotan, between the triangle and the circle. So if we say this is the radius, and this also could be a radius, okay, and this also could be a radius. So he took this triangle and he explained it. This is the angle, and he said sine the radius, this is the radius here, and he said this is the hype. So if the hype is unit 1, then the radius is unit 1. If it's 1 meter, then the radius is, if the hype is 1 meter, then the radius is 1 meter, same thing, etc. So he explained it on this perspective. As can be seen, the applet, it's the sine, okay, this angle equals the function of A. As you can see here, the function of A here is 0.8 and 0.6. So the sine of this angle, okay, is the function of A, and cosine of that angle is the function of, is the x of A, which is 0.8, and y, the function of y of A is 0.6, as you can see here, where x and y are the x and y coordinates respectively of A. Using the coordinates of A instead of ratios of sides and right triangle, we can extend the definition of sine and cosine so they define all for all of the angles. So it could be here, so we can define it on here, and we can define it on this triangle, we can define it on the other triangle, no, on the other triangle here, and you can define it in the rest of the triangles on the circle, as you can see. So instead of defining it between 0 and 90, you're going to define it between 0 and 36 degrees. And when you get older, or when you study more, you can define it on any angle less than 1 degree or more than 36 degree. You can define it on any degrees. So the graph of sine and cosine here, if you enter sine x or cosine x, when you read here, you have to look at the graph. Every sentence you read, or every piece of sentence you read, you have to look at the graph. He says if you enter sine x and cosine x, is there sine x and cosine x? It's not here yet. So he's trying to explain to you, define to you sine x and cosine x. You will see the graph of sine and cosine for all values of x. Okay? The part of the graph that are plotted in the applet above are repeated infinitely many times. The function are periodic to the period is 360, as I told you before. So you can get the sine and cosine for any angle. If function of x is periodic function with period p, then f of x is fx plus p. Well, this is I know it looks complicated, but it's easy. So if we said if we have the normal angles anyone study is from 0 to 90, okay, and then you're gonna have another domain from 90 to 180, actually equals to, or from 180 to 270, or from 270 to 360, or from 360 to something more. Let's say 90. It says we're gonna have 450, and the list goes on. The numbers, the angles get bigger and bigger. Notice that these angles are repeated from this one here. So actually, you in real world, you cannot have more than 180 angles. So if you stretch your hand like that, very straight, you're gonna have 180. That's all. So if you went with your right hand and you put it up like that, then you are decreasing the angles, and you can go down like this. So if you got your hand down to 0, now you're gonna get on the 270, 360 part of angles. So just if we explained it an x and y axis, okay, so this is from 0 to 9, and this is from 9 to 180, and this is from 180 to 170, and from 270 to 360. So all of this is this range, all of this is this range, all of this is this range, all of this is this range. So you're gonna have a perfect circle. Okay, now what I want you to understand is that all the sine and cosine and tan and cotan, all of these from 0 to 9 is similar to sine and cosine and tan. So sine here is the same as cosine here, okay, but sine here is the same sine here with different charge, with different signal. So what I want to say is that all of the sine and cosine in this quart, in this square, in this a quarter, is almost similar to all of these in here. So if you memorize these angles from 0 to 90, special angles, then you're gonna understand everything about the rest of the angles. So this is what he's trying to say here. As you can see, periodic function with period p. So if you have f of x and we have period p, p means which quarter. Is it the first quarter, the second quarter, the third quarter? Is it 5 angles or 6 angles, whatever? So if function of x is a periodic function with the period p, then if we added those together, then f of x is f of x plus b. What do I mean by that? I mean, if we said p is 360, okay, and if x is sine 30, for example, then f of x, which means sine of 30, is f of 360, oh sorry, 30 plus 360, okay, which means sine of 30 equals f 3 plus 360 is 390. So let me try so sine of 30 is almost 1, negative 1. Now let's see sine of let's see, I'm sorry, I should have put this sine. So I should have sine 390. Okay, perfect. So I've got it almost right, because there are a lot of sine 360 is not sine 390, it's something different. It's sine cosine sine cosine, so it's gonna be sine 30 blah 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 blah. I don't want to get you in that, but what I want you to understand is that the period that you're having will not change the sine or cosine of something. So 67 here is gonna be similar, sine 67 here is going to be similar as sine what is in the front of 67 on here, and the whole point goes as it says here, the period is, and the period is 360. This is technical stuff. If you went to GeoGebra or anything and you want to do angles, you press Ctrl and O and rescale x-axis by pressing shift. Okay, now extending the definition of tangent and cotangent. Tangent is sine over cosine, or opposite over adjacent. Let me explain this to you. So we have sine is the opposite over height, right? And cosine is the opposite, is the adjacent over height. And tan is sine over cosine, which means opposite over height. All of this is over adjacent over hype. So hype and hype cancels each other, so you're gonna rest with opposite over edge or adjacent. That's it. So he got it like this way. Now cotan is the opposite of tan, so it's going to be cosine over sine, or adjacent over opposite. And here he gave you exercises. It's pretty much easy exercises. Using the construction of the applet above, show that tan of this angle is y of p for all from 0 to 9. And using the construction of the applet above, show the cotan. Cotan is the opposite of xq. Actually, you can go here and you can find the q and the tan and all of that. The graph of tangent and cotangent. Tangent and cotangent are periodic function with period 180. So the period of cotan and tan is 180, but the period of sine and cosine is 360. Okay, tan is not defined with when the angle is 90 plus 180 and or anything times with 180, and this thing that it times belong to the number group of z. And cotan is not defined when the angle is 180 or anything or factor of 180, so maybe 360 or 3 times 180 or 4 times 180, blah blah blah. So this is the explanation of the website. I hope I did well. Bye.